Okay, so we are back for part two. Part one was all about vocab and kind of getting some ideas together with what words indicate, when to use each inequality symbol. Part two is going to be actually using those inequality symbols and solving some inequalities. So let's jump right back into our notes. Here we are with our first example. So there's one thing that's really different about inequalities, and that's that inequalities end up with these solution sets. So the solution to an inequality looks like this. So it looks kind of like an equation solution, except for it will have an inequality symbol instead of an equation. And the weird thing about these is that there's not just one answer to an inequality. There's infinitely many answers. Okay, that's why we call this a solution set. It's a set of numbers that would be a solution to the inequality problem that we solved. Now, these are not problems, these are solutions. And what we do with them to show that we are or that we have these unlimited or infinitely many solutions is we graph them on a number line. Okay, so this is another thing that's different about inequalities and equations. So the symbols are different, and then it's different because we have infinitely many answers. It's also different because we will graph those answers to show them on a number line. So this x is less than 9. I'm going to show you a little way to solve this. So I'm giving you a number line here. You do not need to use every line on the number line, but you do need to make sure that 9 is one of those numbers. So I'm going to do this: 7, 8, 9, 10. See, I'm skipping a line in between. There's nothing wrong with that. Nobody says you have to use every single number on the number line. So I'm just going to number like this. I encourage you to do the same. And then I'm going to, over my number 9, right over that tick mark, I'm going to put an empty circle. Notice I did not color that circle in. I'm leaving it as an open circle, empty circle, but we're calling it open. And then its x is less than 9, less than 9. So I'm going to start at my circle and I'm going to shade less than. I'm going to shade less than. So I kind of shade up my number line and then I shade my arrow to show that my solution is every number smaller than 9. So that includes 7, it includes 8, it includes 0, it includes negative 4,372. It also includes any decimals, fractions, whatever in between. Okay, so that's what we do to end our inequality problems. Let's take a look at B. B, let me go back to A for a second. Sorry, A. So I knew that less than meant to shade to the left. I knew 7 and 8 were less than 9, but here's a little hack for you. As long as your variable comes first, you can look at your inequality sign and you can shade in whatever direction it points. So if your variable comes first, I can look at this less than sign and I can say, that points to the left, so I'm going to shade to the left. Okay, so as long as your variable comes first, you can use that hack. So now let's take a look at letter B. Letter B, our variable does not come first. Oh, poo. So here's what we need to do. We want to take it and we want to get our variable on the left-hand side. And we do a very, very complex procedure called the flip, flip, flip. Okay, flip, flip, flip. I want you to write this on your paper. It's called the flip, flip, flip. Very high tech here. So what we do is we first flip the variable to the left-hand side, and then we flip the constant to the right-hand side, and then we flip our inequality sign. So right now this is a greater than or equal to. We need to flip it around and make it a less than or equal to. That is the high-tech procedure called the flip, flip, flip. But now that we've done that, this becomes a lot easier to graph because our variable's on the left and that's what we want. Okay, so I need the number 5 on this number line. I'm going to do 3, 4, 5, 6, and 7. Notice again, I skipped a line in between. That's perfectly fine. I'm going to come to my 5 here. I'm going to put my circle on, and this time I'm going to shade my circle in. I'm going to use what's called a closed circle. We're going to talk about why in just a second. My arrow points to the left. It's a less than sign, so that means I'm going to shade to the left, shade down your number line to the left-hand side all the way to the arrow and shade the arrow as well. Okay, so there is my graphed solution. So couple things. Remember to do the flip, flip, flip to get the variable on the correct side. If the variable comes first, then we can use the direction of the arrow to help us shade. That will come in handy with negatives because sometimes negatives are a little bit tougher to shade for some reason. The other thing we need to know is, hey, why did I use an open circle here and a closed circle here? Well, I'll tell you why. In our first problem, it was a less than sign. So all numbers less than 9 were part of the solution, but 9 itself was not. So I can't shade in that circle. I circle the 9 and I shade to the left, but it's an open circle because that was just a less than, no equality. Over here, I have a less than or equal to sign. So the number itself, that 5, is part of my solution. So is every number smaller than it. So because that had an equal to part here, I shade in my circle to show that 5 is part of my solution set. So here's what our notes say. We use an open circle, that was this guy right here, open circle to graph less than and greater than. We use a closed or a shaded circle, so this guy right here, to graph less than or equal to and greater than or equal to. So that equal to piece means shade the circle because the number itself is part of the solution. Let's do some problems. Solve the inequality, graph the solution. Let's get this done. It's nice, it's easy. These are back to like 6.1 type of problems. I know you're going to be like, wow, these are so easy. So variable side, constant side. This might be the way you like to do these now. Which term does not belong on the variable side? It's the 5 subtracted away. Goodbye, 5. Balance it out on the other side, and we're left with m is greater than or equal to 2. So now we have to graph it. So go to my number line. I need a 2 on there, so I'm going to do 1, 2, 3, 4, 5. Put a circle around the 2. I'm shading my circle in. Why? Because I've got an equal to piece here. Now I've got a graph greater than or equal to 2, so the greater than sign points to the right, which means I'm shading to the right. Go ahead and shade your number line all the way to the right, all the way to the arrow, and shade the arrow itself. That is how we show our solution set. That means any number 2 or greater will be true for that inequality. So just for fun, really quick, we are going to test that theory. 5 plus 2 is 7. Is 7 greater than or equal to 7? Yes, it is. Let's try a number bigger than 2. Let's try the number 10. 5 plus 10. Is 5 plus 10? 5 plus 10 is 15. Is 15 greater than or equal to 7? Yes, it is. So that's what we're saying here. Any number 2 or greater can be put in for m, and we will get a true statement there. Okay, part B. I know this video is getting long. This is our last problem we are doing. So you should be in good shape. Variable side, constant side. Which term does not belong on the variable side? It's the plus 30. How do we get rid of a plus 30? We subtract 30. And we do that to both sides to keep it balanced. We get negative 8 over here. We get a greater than sign, and we get the variable k. Oh, that k, it needs to be on the left. We are high-tech flip, flip, flip procedure. Flip the k to the correct side. Flip the negative 8 to its correct side, and don't forget to flip your inequality sign. This is greater than, so I need to flip it to be less than. And now I need negative 8 on my number line, so I'm going to start with negative 9, negative 8, negative 7, negative 6, negative 5. Don't forget, negatives go backwards on the number line. Okay, so solution is k is less than negative 8, so it's a less than, which means I do an open circle. Less than points to the left, so I shade to the left, and any number smaller than negative 8 is a solution to that inequality. One more difference between equations and inequalities, maybe you noticed, I'm not doing a check. With the graph, I'm not going to also force you to do a check. I might just do a check mentally to make sure my answer works. Okay, so think about that, but I won't make you do a written check. Lots of similarities and differences. Please watch this video again. Make sure you notice, because tomorrow we're going to start off reviewing the differences between inequalities and equations. If you have any questions, let me know tomorrow in class. Don't forget to do your practice problems. Don't forget to graph your solutions.